Hello everyone, this is Introduction to Robotics Lecture 1. My name is Georgia Halvadzaki and I will be the instructor of the course. This lecture is introductory. The purpose of this course is to introduce you to the basics of modeling, design, planning and control of robotic systems. Every week you will get an assignment. It could be a programming exercise or a homework of analytical exercises. More precisely, the content of this course will contain learning about space transformations, transformation of rigid bodies, forward kinematics, inverse kinematics, static analysis of robotic manipulators, dynamics, robotic control, linear and non-linear, introduction to motion planning, introduction to robot programming. We will see more precisely those concepts in the weeks to come. Good luck, everyone! What is a robot? A robot is a mechanical or virtual artificial agent, usually an electromechanical machine that is guided by a computer program or electronic circuitry. Robots can be autonomous, semi-autonomous, or remotely controlled, and range from humanoids such as Asimo and Topio to nanorobots, swarm robots, and industrial robots. By mimicking a lifelike appearance or automating movements, a robot may convey a sense of intelligence or thought of its own. The branch of technology that deals with robots is called robotics. Joseph Engelberg said, "I can't define a robot, but I know one when I see one." Let's see the categories of robotic systems. There are the industrial robot manipulators. An industrial robot is an automatically controlled, programmable, multi-purpose manipulator programmable in 3 or more axes. The field of robotics may be more practically defined as the study, design and use of robot systems for manufacturing. Typical applications of robots include welding, painting, assembly, pick-and-place such as packaging, palletizing, and SMT, product inspection and testing, all accomplished with high endurance, speed, and precision. Another category that we will examine thoroughly this year is the dexterous robots. There are also the redundant manipulators. They are included in the dexterous robot. A manipulator is termed kinematically redundant when it possesses more degrees of freedom than it is needed to execute a given task. Redundancy can be conveniently exploited to achieve more dexterous robot motions. We will see more about this in the weeks to come. Another category is the mobile or servo robotics. A mobile robot is an automatic machine that is capable of movement in any given environment. Mobile robots have the capability to move around in their environment and are not fixed to one physical location. Mobile robots are sent in Mars, as an example, to explore the environment of Mars. So they apply in space robotics. There are also mobile robots that are used in hospitals, like nurses. We will talk about mobile robots and mainly about motion planning later in this course. Next, the final category that we will see is the micro-robotics, such as the insect robot. You will see here a spider and a fly. Micro-robotics or microbotics is the field of miniature robotics, in particular mobile robots with characteristic dimensions less than a millimeter. The term can be also used for robots capable of handling micrometer-sized components. Due to their small size, microbots are potentially very cheap and could be used in large numbers, such as the swarm robotics, to explore environments which are too small or too dangerous for people or larger robots to explore. It is expected that microbots will be useful in applications such as looking for survivors in collapsed buildings after an earthquake or crawling through the digestive tract. What microbots lack in brain or computational power, they can make up for by using large numbers, as in swarms of microbots. Now let's talk about the laws of robotics given to us by Isaac Asimov. First, a robot should never harm a human being. Secondly, a robot should obey a human being unless this contradicts the first law. Third, a robot should not harm another robot unless this contradicts the first or the second law. Let's see the levels of robot control. At the lowest level, we want to ensure motor driving robot joints or wheels are used in stable configurations. We want to see that there are no oscillations. At the next level, we want to ensure that no collisions occur. We also expect robots to perform other intelligent behaviors. Here is a diagram about the robot's control system. We have the human input. We have the goal setting and the global planning. This is an input for navigation and obstacle avoidance. Then we go to stability, attitude control and servo control. And you see how these actions are separated from high-level control, intermediate-level control and low-level control. So this is for now. In the next lecture, we will continue with the space transformations and the introduction to forward kinematics. See you in the next video.